a video for section 6.4. This should actually be a lot of review. We've done a lot with factoring already, but we're going to be factoring some polynomials. So this is important to know that if x minus a is a factor, it's only the case if a makes the polynomial equal 0 when we evaluate it for a. So x minus a is a factor if and only if p of a equals 0. Okay, so how do we check that? So if is x plus 1 a factor of this polynomial? So a in this case then would be -1. Remember, it's the opposite. So I can check that using synthetic division, right? If I get a remainder of 0, that means that this is a factor. So I'm going to use synthetic division here, list my coefficients. -1, add. All right, so I get a remainder of 5. So this means x plus 1 is not a factor of x squared minus 3x plus 1, okay? So if I got a remainder of 0, it would be a factor. If we get anything other than 0, it's not a factor, okay? So let's check -2 with this polynomial. Okay, so we have 3x to the fourth, 6x cubed, 0x squared, -5, -10. All right, bring down the 3, multiply, add, -2 times -5 is 10, so we do get a remainder of 0. So this would be, yes, x plus 2 is a factor of this polynomial, okay? All right, so speaking of factors, right, factoring, we had a lot of different strategies. So one of the big things we want to focus on is always checking for the greatest common factor first and factor that out immediately, okay? Then we have these different strategies depending on how many terms there were. So if it's something with 2 terms, we want to look for difference of squares or sum and difference of cubes. Remember, there's no such thing as sum of squares, so we can't factor that further. And then if it's 3 terms, we have, you might recognize perfect square trinomials, and then these are all different methods for factoring trinomials. The one that I teach is the reduce and bottoms up, but depending on who your teacher is, you might have seen some of these other methods as well. And then lastly, 4 terms, we are going to factor by grouping. All right, so let's try it. All right, factor. All right, so this one has 4 terms, but first let's see, is there a GCF I can take out of all 4? Doesn't look like it. So factor by grouping if it's 4 terms. So I'm going to do 2 at a time. So here my GCF would be 4x squared. So by taking out the 4x squared, right, what's left is what happened after I divided by 4x squared. So 8 divided by 4 is 2. By taking out the x squared, I only have 1x left. We took out 4x squared from 4x squared, so I just have -1. This sign, right, remember we keep that, so I'm taking out something negative. The GCF for these 2 is 25, so I'm dividing by -25, which can make this a positive 2x and a -1. And remember, that's the goal, is we want what's in parentheses here to match. So now that's the GCF that goes in front, and these are the remaining factor. Now we actually can go a step further because this is difference of squares. It's subtraction, 2 terms that I can take the square root of. So the 2x minus 1 stays the same. This one, the square root of 4x squared is 2x. Square root of 25 is 5. And remember, we have 1 positive and 1 negative. So that would be completely factored. All right, here I have 2 terms, and I have something cubed. So I'm thinking this is this difference of cubes. So can I take the cube root of both of these? Yes. Cube root of x cubed is just x. Cube root of 8 is 2. So with subtraction, here's what it factors be if you need to flip back over and look at the formula. It's a minus b, so x minus 2, okay, times a squared plus ab plus b squared, and then that's factored. Okay, so it's just using the formula for sum of cubes and being able to pick out what are a and b. We have, or excuse me, difference of cubes here. Here I have sum of cubes, two terms being added, and they both, I can take the, cube root of. I'm actually going to rearrange this, you guys, to put it in standard form. So I'm just going to call it x cubed plus 125. Those are the same, right? Addition, the order doesn't matter, but I'm going to write it in standard form. So a here is x again. Cube root of 125 is 5. So sum of cubes is a plus b. So x minus 5. Why did I say that? X plus 5. Okay, and then a squared minus ab plus b squared. All right, and then that is factored. All right, here I have two terms. Again, I'm going to write it in standard form. Okay, I'm looking, this isn't sum or difference of cubes, but I do have a GCF I could take out of both those. I could take out a 3x squared, so I'd be left with 1x cubed plus 8. And then this, what's left, is the sum of cubes, where a is x and b is 2. Just like we did up here, it was difference, this one is sum, so I still have that 3x squared out front. And then I factor using the sum of cubes formula. And so this guy would now be completely factored. All right, 4 terms, and not seeing a GCF for all 4, so jump into grouping. GCF y squared. Okay, plus sign carries down here. Second group, GCF would be 2. Okay, parenthesis groups match, so pull that out. What's left is y squared plus 2. This is not difference of squares because it's not subtraction, and also 2 is not something I can nicely take the square root of. So this is completely factored. All right, and we have one last example here, you guys. This is a graph that we're going to check out. It says the volume of a plastic storage box is modeled by this function. Identify, and this is the function that's graphed here. Identify the values for which v of x equals 0, and then use the graph to factor v of x. Okay, so v of x, think of that as our y values. So we want to look for where is y 0. So that happens anytime the graph crosses the x-axis. So v of x equals 0 when x equals -5, -2, and +1. So these are what we would call the zeros of the function, okay, or the intercepts, right? The roots, zeros, intercepts, solutions. Those are all synonymous, okay? So remember, zeros are not the same as factors, but they are very closely related. So once we have the zeros, I want to put it in factored form. So I have 3 zeros, so I'm going to have 3 factors. And this is what v of x is going to equal in factored form. So this is what it is in expanded form, standard form. In factored form, remember, all I have to do is use the opposite of the zeros. So if it's -5, x plus 5 is a factor. If -2 is a 0, x plus 2 is a factor. If +1 is a 0, x minus 1 is a factor. So we can use zeros from a graph to factor a polynomial.